Okay, then let's do this. Welcome everyone to Introduction to Topology number 3. I am Thomas / Guilty Gyoza from Topology. This is a high-level talk for what our work, the why behind the work, what is our work, and the so what question. We're hoping to answer the so what question for you in this call. So let's start with what everyone in the blockchain space knows about, which is consensus and execution. Now, there's a lot of saying of these two words, consensus and execution. For those of you who just came back from DEF CON, people talk about consensus and execution, how different projects are doing that differently. Now, why do these things matter at all? Why do people in the blockchain space talk about consensus and execution all the time? We argue that these two terms are not the first principle way of thinking about the problem. Now, what is the problem? The problem is, in one word, we want to make a great work computer, right? We want to be able to build together on a computing substrate and grow together and build communities and evolve together. From that problem, how to make a great work computer, we argue that consensus and execution is not the best way to think about this. Instead, a much better way to think about the problem is space and time. We think about the space and we think about time. How do we combine space and time to make a better work computer? So let's start with space. When it comes to making digital worlds and building in the digital realms, it is not a coincidence that we can learn a lot from architecture and urban planning and the reality. So this is a book called The Pattern Language, written by an architect in the last century. And it turns out that we can learn a lot from the reality of making architectures and urban planning. Now, how so? So in the book, there's this statement that if you have a city that is very homogeneous and undifferentiated, where everyone can go everywhere and there's no boundaries, then this kind of city kills life. It kills different varieties of lifestyles, and it basically stops the growth of individual characters. What does that mean? It means that you have a city where there's no boundaries, everyone is at the exposure and interaction, forced interaction from everyone else. In that situation, you are killing the diversity and you're killing the varieties. Instead, if you have a city where a large number of subcultures that are each relatively small in their size, and also they're separated from other subcultures by boundaries, and these boundaries are empty lands. They're not inhabited by people. You can have prosperous subcultures. In the digital realm, we have seen that already on the internet. We argue that the internet has killed subcultures because we have lots of social media platforms that are massive and global, and they, on the incentive standpoint, they don't really care about subcultures. Instead, they care about attention maximization. And as they care about attention maximization, it is in their interest to have redirect everyone's attention to where there is most attention. So they're not interested in keeping the boundaries between different communities and societies and subcultures. Instead, they're interested in redirecting everyone's attention to where they can create the most eyeballs and obviously profiting from those activities. And in such a global social media that is homogeneous, subcultures are being killed. And so it is being argued that subcultures are dead on the internet, but we actually want subcultures to have more diverse societies on the internet. So we are looking for digital tools for us to make a subculture-centric world. And in this situation, we want to enable these subcultures and have them and make them sustainable. And they don't need to scale. The key here is subcultures do not need to scale. They don't need hormones that grow very fast and die in one peak. Right? They can sustain with just the people that are interested in those cultures, and they interact with other communities at their own will. Coming back to the book, it would be great for subcultures to prosper if we have a vast mosaic of small and different subcultures, each with their spatial territory and each with their power to create their own distinct lifestyle. If we have to sum up this entire statement in one word, that one word is sovereignty. Hashtag sovereignty. You want to have communities and subcultures that enjoys sovereignty. So they have control of their own territory. They have control over how they want to interact with other communities. And they, within their boundary, they can create their own distinct lifestyle. So we move on to another dimension, which is the time dimension. On the time dimension, it is quite obvious that Bitcoin is a notion of time, but it is not the most powerful notion of time, right? So from the original Bitcoin paper, we all know that Bitcoin is time. Bitcoin is a centralized timestamping server. The block time is the Bitcoin's time. Now, in one way, we can understand Bitcoin's time as absolute space-time, in a sense that at every moment in Bitcoin's time, you know the global state of the entire Bitcoin universe. You know what's happening everywhere in the Bitcoin universe in each block. And that is basically the idea of absolute space-time. And this is really classical in the sense that as we move into the modern times, relativity was discovered, right? And this is a little sort of journey into physics. When it comes to the modern times physics, we have relativity. And what does relativity mean? It means that whether or not things happen at the same time depends on where you are observing from. What does that mean? It means that in this thought experiment, how long has the light traveled to reach the detector? The light goes up to the mirror and goes down to the detector, right, inside the rocket. Now you ask the question, how long has the light traveled? Now that question really depends on if you are inside the rocket or if you're outside the rocket, right? If you're inside the rocket, it goes up and down. If you're outside the rocket, because it is moving, light travels a longer distance to reach the detector. So it is a relative concept. Now, the one interesting mental model that's relevant here is called the light cone. And the light cone means that if you have something that's happened in the universe and you plot it in the origin of your chart, the y-axis is time, the x-axis is space, then you have light cones. And light cones, the light cone pointing downward covers all the events in the past that could have influenced you sitting at the origin. And a light cone on the top covers all the events in the future that is possible to be influenced by you, again, at the origin. Right? So you have a path drawn from the past, passing through the origin into the future. That means you have some cause and effects. Some things happen in the past that are connecting to each other and influencing you at the origin, where you serves as a cause and you're causing this chain of events happening into the future. Now the question is, what happens in the shaded area that are outside of the light cone? Well, the question is even more radical. Why do we need a light cone here? Well, because information doesn't travel at infinite speed. Information travels only as fast as light travels. And so you could not be influenced by everything in the past. There's something in the past that are so far away from you that they haven't got time to reach you, yet you happened already, right? So that they are outside of the light cone. They're independent of you. From a cause and effect perspective, they are independent of you. They're just simply not related to you. And if we think about the shaded area, we no longer have global state. Okay, we no longer have perfect knowledge of everything that has happened in the universe, because in the shaded area, you don't know them. They're independent of you at the origin. This is obviously diverging from the Bitcoin's notion of time. This is a more modern interpretation of time. We argue that as we go from the classical notion of time to this more modern notion of time, where we embrace the idea that the universe is so vast that there are a lot of things that are happening independently that are not exactly affecting each other because they're so far away from each other, and information only travels as fast as the light travels. If we embrace this fact, we go modern, and the implication is we get to explore the cosmos. We get to build better technologies, and we get to explore larger spacetimes. Now, what does that mean in the digital realms? It means that as we embrace a better, more modern notion of space and time, we can build larger digital realms with more actors, with many, many more things happening at the same time in this much, much bigger digital realm. Okay, and so one key thing here that is important, and this is a little bit technical, and we're hoping to keep it simple, is that if you embrace the idea that things can happen independently, you don't want to tie them together. You want to avoid forcing a relation between them. So if one thing happens here in the universe, another thing happens there in the universe, you don't want them to have to coordinate and talk to each other before the universe moves forward, right? The universe moves forward regardless. These things are independent. Now, this is some wisdom from the Amazon Web Service engineer that if you want to build a very scalable system, you want to better coordination down to a minimum. You don't want coordination. You want to move them off the critical path. You want to hide them in rarely visited corner of the system. You better not see them. And you want to make it as hard as possible for application developers to even get permission to use them. So basically, coordination is bottleneck, and you want to stay out of the path, stay away from your applications as much as possible. And this is coming from the wisdom of making a much, much larger and more scalable distributed systems than any blockchain we have in the reality. So there's something here that we can learn. Avoiding coordination so that we can embrace independent things happening in the vast, vast universe. Okay. And there's one technology that happens to embody this concept and this idea that is called CRDT. And furthermore, this technology has been made BFT. BFT is just a fancy word of saying that you have a lot of bad actors that are in your system and they're doing bad things. But the good guys functions as usual. They do their business as usual. If you can allow this, then your system is great. It's Byzantine fault tolerance. It's tolerant to bad things happening and bad actors present in your system. The key takeaway here is CRDT is BFT. So we can use CRDT to make systems that are robust to bad actors and as robust or even more robust than blockchains. Now, to prove that this is actually not a delusion entirely, we made this POC a year ago where you have a platformer 2D game where our colleagues were logging into the same game and playing together. And this was happening in a totally distributed manner. There is no centralized server in the middle, and there's no blockchain involved whatsoever. This game runs simply between the laptops of our colleagues, and it is running at 30 frames per second speed. So this is running in real time, very responsive, and it runs P2P. So now we bring your attention to protocol. Why protocol? Because the CRDT technologies have been around us for more than a decade. It has been deployed in many, many places, from geo-distributed databases to behind Apple's own technologies, behind editors that support multiplayer editing mode. So there are also many, many implementations and libraries on the market that are embracing and advocating for this technology. So we think that the time is ripe for this technology to pursue the path of protocolization, which means that this technology is so great and is so useful in many different areas. It is useful for us to write down a protocol or a standard way of doing this and to have it support applications. And if we can protocolize this, we can have many applications that are able to talk to each other, and we can avoid fragmentation. So we see a lot of value in doing a protocolization of this idea of vast space-time, of running programs in real time, and embracing the idea that things can happen independently and so on. So we're making a protocol, and this protocol is called DRP, which stands for Distributed Real-Time Program. DRP is an open internet protocol to bring real-time sovereignty to the work computer. Okay, so the key affordance we want to bring to the work computer is real-time sovereignty. Work computer already offers sovereignty on the internet, but the work computer has been running in blockchain's term, block time, the classical time, and that is never going to be real time. So we are making this protocol from a complementary position so that together the work computer can run in real time. This is an open internet protocol, not a blockchain protocol. So this is not another layer 2 on the market or another crypto protocol. Instead, this is a protocol that we wish in the future to drive into the internet protocol stack. Once we have sufficient adoptions and use cases and implementations that are justifying that this protocol is a useful value add to the world of the internet, we can drive it to the stack. There is a entire community and movement outside Web3 that's called the Local First movement, and they recently hosted a conference. In that conference, the argument was that this technology, this CRDT technology, the technology that we're making our protocol on top of, is possible to be standardized in 3 years, which means that it is possible for this technology to have so many use cases and adoptions in the real world that it deserves to be standardized on the internet, and it can happen in 3 years. So our work with DRP is we want to drive that adoption, drive that protocolization, and drive that standardization on the internet. This slide is going back to the root of topology. So at the genesis of topology in 2021, we believe that the open metaverse, the metaverse, is accomplishable in a decentralized manner. And we still believe so. And with DRP as a protocol, we really believe that this protocol is a meaningful shot to accomplish the idea that we can have 100 million concurrent users all interacting in a shared 3D simulation that are running as fast as 60 frames per second. And more so, we want to achieve this in a decentralized grassroots fashion. Now, why do we say that, a decentralized grassroots fashion? Because all the major commercial players that are currently trying to push the metaverse vision, they are not interested in the decentralized fashion or manner of doing this. They are advocating for huge corporate networks that are federated together, and on top of those networks run the metaverse that they want everyone in the world to participate in. Now we're arguing from the other side and say we can achieve that vision or even a better, more colorful version of that, and in a decentralized fashion. And in order to do that, we need to push from a protocol standpoint. We cannot push from a commercial platform standpoint. So this is another reason why we strongly believe in this direction of making an open internet protocol that is free for use, free of permission, and free of cost for everyone to use. So this is the Telegram group chat where our community hangs out and asks questions. If you are aligned with our vision, come join us and let's make this vision a reality together. The GitHub link is where we have all our open source code available. All our implementations and our work is in open source for everyone to see, to review, and to use. So this is the first half of the talk. I'm going to pause here and wait for questions. Are there questions in the chat? We can have a quick Q&A session now, because what we also have following this slide is a very quick technical overview of the protocol, because I believe that some of the audience are interested in, so what exactly is in DRP? Why is it able to support real-time sovereignty? And I think it is useful to give a technical walkthrough of DRP. But before that, let's have a Q&A session. Okay, since I cannot see the chat, I am going to stop sharing my screen.
Are no questions in the chat. I don't know if you can hear me.
Okay, I can hear you now, actually. Mm-hmm.
Okay, we have a question.
Okay.
How does
Yes,
Byzantine fault tolerance works? How to detect these errors?
Yeah, I'm seeing. Okay, so how does Byzantine fault tolerance work? Now, that is a very big question. I assume you're asking, how does it work in DRP? So answering that is a little bit tricky, but I can tell you that DRP is more tolerant to bad actors than any blockchain. And you will, if you have stayed in the blockchain space, you will know that one core tenet all blockchains share is they are tolerant to Byzantine faults. Well, otherwise you have centralized change and permission change, and we don't want to go in that direction now. So DRP offers stronger tolerance to bad actors in a system. Now, if Byzantine fault tolerance is too multiple for you, let's just say bad actor tolerance. And DRP is more tolerant to bad actors. The reason is that for DRP, remember in the presentation we talked about the cosmos is so vast that things happening here and things happening here are independent to each other, right? And it doesn't make sense if we have to stop the universe and coordinate these two things, events that are very far away from each other, and have some kind of agreement that, hey, you know this and you know this too. And then we unpause the universe and have the universe make progress, step forward. Okay, but what I just described, the pausing, let everything coordinate with everything else, and then unpause the system and let it step forward, that is precisely how most blockchains work. And that's why we call it the classical way of space-time. It's tick after tick after tick, and every tick you know everything that happens in the universe. So you don't allow things that are very far away and independent to each other. But in DRP, we allow that. We allow things that are very far away to not have to know each other or coordinate with each other, but the universe still moves forward. And in such a manner, we don't have to have agreements among different events, different occurrences in different places of this vast, vast universe. And if we don't need agreements, we don't need to have all kinds of elaborate systems that blockchain employ to do agreements. Perhaps you have heard about POW and POS, maybe. Proof of work and proof of stake. Proof of work and proof of stake, these are different ways for blockchains to basically agree on things. So proof of work basically means we will agree on the version of the history where there are the most computers behind that history that were computing that history. And POS, proof of stake, means that everyone agree on the history that is decided by the people that have the most money at stake in the system. In order to write history or participating in history making in a POS system, you have to sort of put money at stake in the system and say that and swear that if I do wrong things, my money gets taken away. And if you make this sacrifice, you participate in the making of the history of a POS system. And then agreements are made depending on how much money you put in the system. In such a system, you would have tolerance of bad actors, but they are limited in the sense that if you have super powerful bad actors coming to your system that have a lot of machines, they can break your POW system, right? Or in your POS system, if you have a super powerful bad actor that are super rich and they're willing to put up a huge amount of money at stake just to break you, they can break you. So that is the limit of how blockchains tolerate bad actors. But in DRP, we don't require such agreement to work. And so we don't need POW and we don't need POS. And we can tolerate 99.99% of bad actors in the system. The key thing here is as long as the good actors can still talk to each other through each other. Like, so for example, if you and I are good actors, and Patty is also a good actor, and if you and I can talk to each other through Patty, then our universe is going to make progress correctly. It is going to just function correctly, despite all the actors out there may already gone bad. Okay, our universe maintains total correctness. That is a very long answer to your very short question. How does it detect and prevent these errors? For that, if you're interested in the technical details, we encourage you to go to the white paper of the protocol or our blog post. We have blogs.topology.gg. It covers some of these ideas in the blogs. But I think if there's one takeaway I want you to have from this conversation, it is DRP is more tolerant to bad actors than any blockchain. New question. Jimmy asks, can you elaborate more on why they estimate that 3 years could lead CRDT's technology to meaningful usage in a local first event? I think it's I have no idea why 3 is the magical number here. But I think 3 is a signal of high confidence. Won't you agree? Like 1 year feels very unrealistic. If something is going to happen next year, then it must be already a hype this year, right? But we all know that CRDT is not a hype yet. But 3 years is not a very long time, but not a very short time. And I think it basically represents how confident the local first community is about for this technology to become much more useful and much more ubiquitous on the internet. This is a psychology question. So to me, 3 means confidence. And Patty just left the link blog.topology.gg. There you can find currently 2 blog posts that are covering the core ideas behind the protocol, and the language there is supposed to be very approachable, so you don't have to have technical knowledge to be able to understand the blog. Okay, so Jimmy has a follow-up question. Yep, agree. I just curious why they have such high confidence. Well, you know, CRDT has been around for a long time, right? It was conceived of around year 2007, and it was conceived of in 2 different places in 2 different names. And a few years later, in 2011, they converged into the same name, which is CRDT. And this is 2011. Past 15 years, we have many startups going through hype cycles and many Hacker News conversations about this technology, and many production-ready solutions using this technology. On top of their database solutions, run lots and lots of applications that are stress testing this technology. And it has gone through many hype cycles. Now, this is to note that not just Web3 has hype cycles. Outside Web3, the tech space also has different narratives and hype cycles going on. And CRDT has gone through many such cycles. Currently, it's called the local first movement or the local first principles. Before this, it was called offline first. There was a previous incarnation, and it was called a different name. So I think going through all these different hype cycles and drawing so much attention and making so much real world deployments and stress testing itself, and also discovering the entire space of problems that need to be solved for this to be useful. And also, we have a lot of libraries using CRDTs that are free for use and powering real world applications, actually. So I think all of these data points are proving that something is at the cusp of the horizon. CRDT is a very mouthful word, right? And technology is not even the most important thing here. The most important thing here is, hey, we can have multiple people running the same applications and interacting with each other as fast as they want. And they can do this without relying on a single machine to be alive, whether that be the cloud or any one server or blockchain in this sense. And that is just a very useful paradigm to make very robust multiplayer applications. So from real-world deployments, from stress testing perspective, from the number of academic papers that have been published on it, from the number of startups that have been making progress, pushing the limits of these technologies, and from the core usefulness of this technology itself, I think there's a lot to be confident about the imminent, much bigger adoption of this technology. I would encourage you to basically search for Local First Conference on YouTube, and you can find all the recordings of the talks there. And in the opening talk, you can hear from the sort of spiritual leader, one of the spiritual leaders of the movement, in his own word, why he's making the 3-year prediction. I wasn't paraphrasing him at all. Okay, we have another question in the chat. from Hatsume. Are you aware of any layer 1s or layer 2s today that have close or similar concept or use hash graphs that are similar to DRP? I only briefly know like Hedera or Phantom, maybe. What are your views on their architecture? Well, so if you understand how Hedera works and understand how Phantom works, there's this commonality between these projects and a design decision of DRP, which is the use of hashgraph. Now, hashgraph was not mentioned at all in the talk that just happened, so we are already sort of jumping into the second half of the talk. But hashgraph, for context, is just this data structure that we're using to represent every program built with DRP. It's a data structure that records everything that has ever occurred in your DRP program. It is the source of truth of your program. And more so, hashgraph is something that doesn't sit in a single machine. We're not making a centralized architecture at all. So if you have a DRP program that are running between Alice, Bob, and Charlie, 3 people running the same program, then this program would have a copy of its hash graph sitting in Alice's machine and Bob's machine and also Charlie's machine. And Alice and Bob and Charlie, each of them is able to access their own hash graph and make updates to their own hash graph as fast as they want. No one is blocking or waiting for anyone else. Okay, and these hash graphs, because of the design of DRP, these copies of the hash graph are going to magically synchronize with each other so that they become the same, or in other words, they become consistent. And so Alice, Bob, and Charlie will end up seeing the same view of the program. Now, there's some similarity between this part of the DRP design and the Hedera and Phantom, but I would say the commonality here is pointing to the truth here, which means that in order for scalability, and we need to have concurrency, and hashgraph is simply the data structure that makes the most sense to enable concurrency. So that commonality points to the truth here, which is this is a useful data structure that embraces concurrency naturally, and this data structure also is tolerant to Byzantine faults. And so we're taking this data structure and we're making an internet protocol out of it. We're not building another small contract platform from this technology for people to make small contracts on top of us. No, we are making an internet protocol free for use that are just for building around this core idea and this core data structure and its capabilities. Do I have views on their architecture? I think that DRP is definitely not invented in a vacuum. The design of DRP, and DRP has many components, right? But the design of DRP really stands on the shoulders of many, many giants. There's so many giants and predecessors and a lot of great projects in the past that it's very difficult to count them, actually. And with DRP, our focus is really taking the best idea possible and really focusing on the core goal, which is we want to have programs that are running in real time and in a distributed manner without relying on any centralized machine whatsoever. And we're focusing on the goal and we're taking all the best possible ideas to achieve that goal. And also, it is important for us to make sure that building with DRP is as simple and straightforward as possible. Or in other words, we really care about developer experience. And I think that's probably differentiate us from other small contract platforms in the sense that we don't assume that we're going to support small contracts, and we thinking from a smart contract platform perspective, if in 2024 you want to make another smart contract platform, I think one thing you have to do is to study what other smart contract platforms have as their features, and you want to have feature parity with them, right? Because you're competing with them. So you're already assuming that you are going to compete with them, and you're trying to make this technology fit with the features. Now, we're really coming from a different perspective, which is there is this new kind, there's a way to have concurrency and running in distributed programs in real time, and we're going to make this as easy to build with as possible. And they are not smart contracts, so we never say that you can make smart contracts on DRPs. They are simply different constructions. They have different trade-offs and different properties. But we're going to make it so easy to build with that every developer has a chance to try it out and to make something interesting and useful for them. And by doing so, we truly believe that new use cases and new kinds of applications can come out because of the DRP protocol. I think to sum up, my honest opinion on Hedera and Phantom would be these technologies that are common between our architecture exist for a very long time in the industry, also in the academia. And I think that it's probably a mistake to try to make a smart contract platform out of it. Is that this technology is going to support a very different kinds of applications with very different kinds of capabilities. And so already assuming that they're going to enable smart contract, I think it's a big assumption. And it is an assumption that we're not making here. Great. If there's no more question, we are actually approaching time limit. So I think it actually makes sense to not do the second half of the talk. It is a technical talk, and we can push it to perhaps the next community call. What do you think? Or the next intro to topology call?
Yeah, we can. For the next community, it would be perfect.
Mm-hmm. I think that's good. So we can consider in the next community call to give a quick technical introduction to the DRP protocol before we give protocol development updates. And with that, any questions, feel free to ask now or in our community channel or on Telegram. Otherwise, I think this is a good time to wrap up the call now.
Thank you, everyone. Thank you for
Bye,
joining.
everyone.